Hello and welcome to this presentation from Ensighten. My name is John Wallace and today we're going to talk about web skimming attacks, how they happen and what you can do to protect against them. Before we dive into how an attack happens, I want to first talk about why web skimming attacks are a serious concern. The fact is that recently the web browser has become an attractive attack surface for hackers as organizations have gotten better at protecting their infrastructure. In one of the previous webinars that I did, I explored the history of attacks and we saw how organizations have gotten better at protecting their servers and origin, and as such, attackers have shifted their attention more to the client. And as the web has exploded in popularity, websites have become incredibly rich and immersive. And while this is most certainly a good thing, most websites today have enormous code bases, meaning considerable opportunity for holes and exploits to exist. These, of course, being what hackers look to take advantage of. Another thing to bear in mind, and as we talk about this shortly, is that skimming attacks take place in the user's browser. That is, they steal data as users enter that data into website forms or utilize cookies. Because of this, the stolen data doesn't come directly from the web server, and as such, it's often difficult to see web skimming activity happening, at least from a website operator's perspective. And when organizations are breached, the data is stolen, the penalties that can be given by bodies such as CCPA and GDPR can be staggering. CCPA law, for example, allows organizations to be fined up to $2,500 for each user affected in a breach. For a site with 10,000 users, this could equate to around $25 million in penalties should the website experience a breach as a result of a web skimming attack. But one of the most concerning aspects of any web skimming attack is that your website infrastructure doesn't need to necessarily be breached or accessed by the hackers in order for web skimming code to be injected into your website. Attackers instead can target one of the many third-party components which you probably make use of. As already explained, today's websites are incredibly rich and immersive and more likened to traditional applications than they are of the websites of old. Instead of pages of static text and images, today's sites allow users to fully interact with them and conduct almost any aspect of day-to-day living, from banking and shopping to conversing and dating. But to create these modern websites, developers have to write thousands of lines of code using programming languages such as HTML and JavaScript, as well as utilizing an array of third-party components. Third-party components allow developers to implement huge amounts of functionality without having to write the code themselves. If a developer wants to include a chatbot on the site, for example, they could utilize one of many open source libraries which provide bot functionality, oftentimes by including the library within their code base. By utilizing third-party components, developers can create amazing websites quickly with an abundance of capabilities. Most websites today utilize between 40 to 60 third-party components. In the example shown here, the cnbc.com homepage loads 69 JavaScripts from domains or locations other than cnbc.com, including Google, Twitter, and an array of lesser-known organizations. When developers use third-party components, they often opt to have them loaded from the repositories of the third parties who provide them, both for convenience but also potentially performance benefits too. For example, When developers make use of jQuery, a very popular JavaScript library, they will often opt to have the script delivered from the jQuery CDN instead of hosting a copy of the script on their own web servers. What happens in this scenario is that developers include what is known as a tag inside their HTML files, which then instructs the web browser to download additional code. In the jQuery case, this code would come from jQuery's CDN. After this, the HTML files which the developer has produced, known as first-party code, are delivered down to the user's browser when the user requests to see the website. Once those files go down to the browser, the additional code is then also downloaded by the browser too. This is known as third-party code. It is common to find many tags within HTML files. As said, developers include between 40 to 60 third-party libraries within the average website. This means that the user's browser downloads between 40 to 60 additional pieces of code along with the main website files. What makes this especially concerning is that there is no security barrier between the first-party code and content and any third-party code downloaded too. In the browser, it all gets executed together as if it was written by the website developer. So if a user was to enter their credit card number into a HTML form field, any code contained within any one of the third-party libraries from any one of the many different repositories could, in theory, capture what the user was entering and steal that information. So with this concept, let's explore how a simple web skimming attack happens. As we have explained, generally a developer will create a collection of HTML files, images, style sheets and scripts, which in turn make up the base of their website code. These files are then hosted on a web server, and when a user visits a site, they are delivered from the web server to the user's desktop or mobile browser. Now the developer would have included tags within their HTML files indicating that the browser should download additional code. Code that will probably do everything from implement chatbots to provide a shopping cart so users can purchase goods. When the browser passes the HTML files from the developer's server, it will then download additional code needed from the required third-party repositories or third-party locations. You should note that this additional code is pulled directly from the third party by the browser and does not pass through the developer's web server at all. Now consider a hacker now finds a vulnerability within one of the third-party libraries used by the website, which gives them a way to alter the code files stored on the third-party repository. The hacker there now inserts some skimming code into one of the existing script files, hiding it amongst the many thousands of other lines of code so that it's difficult to detect without resulting to heavy forensic analysis. The web skimming code, now included in what otherwise is a legitimate JavaScript library, now waits to be downloaded to a user's browser. Now, when the user's browser downloads the third-party libraries, the code they download includes the malicious skimming code that was placed there by the hacker. Because the browser downloads this code directly from the third party, the developer has no logs or indication that the code exists, or that even something suspicious is happening. With the malicious skimming code now running in the user's browser, whenever a user enters a credit card number into, say, the checkout form, the skimming code captures the number and sends it to a server controlled by the hacker. the hacker collects the personal information from several customers, after which they sell the stolen data on the dark web. The skimming code doesn't stop the website from operating normally, and the transactions go through as they should. Instead, it simply monitors for the data being placed into the forms, where it copies the data unbeknown to the user. Skimming code usually runs on a web server for weeks, on a website for weeks before the website operator discovers it. And they only usually discover it because a credit card company has alerted them to the potential fraudulent charges experienced by their customers after they had visited the website. And while third-party scripts make an easy target for hackers, as they're often outside of the control of the website developer, hackers also look at holes and vulnerabilities within first-party code as well, and will happily attack servers belonging to the developer if holes exist. Using the website public www.com and searching for cdnjs.co, a domain known to host web skimming code, we actually find a bunch of websites which currently have tags present referencing the malicious URL. In the results shown here, we can see that 24 web pages contain the domain cdnjs.co. However, that domain itself is one of hundreds of domains used by web skimming attackers. If we examine one of the websites, we can see the skimming code loaded within a script called masm.js. And unless someone is an experienced developer or has experience with JavaScript code, it's not really obvious that the code is designed to skim users' data. In another example, we can see the skimming code loaded within a library called nexi.js, but the code is exactly the same code shown before. Oftentimes, attackers will use the same skimming code across multiple sites until it is detected and the malicious domain is closed down, after which the attackers may change their code and they'll simply switch to another alternate domain that they own. If we do analysis on the cdnjs.co domain, we'll see that it's actually hosted on a server located in Russia. So now that we understand how a web skimming attack happens, and that unless we are able to ensure that code only ever comes from our own servers and is fully inspected, let's understand what we can do to mitigate or limit the effects of a web skimming attack. One of the most basic recommendations in security is to patch and patch often. The reality is that developers are fallible and mistakes within code happen, sometimes leaving holes which are then exploited by hackers. In all web skimming attacks, the hacker first gained access to be able to write to what otherwise would have been a protected file. And while sometimes this access is a result of badly configured servers or a server that wasn't effectively locked down, it's also often through exploiting a hole in either the web server software or the website code. When library developers become aware of issues, they provide update in the form of fixes or patches. And anyone using these libraries should move to apply them, especially security-related patches. Likewise, developers and website operators should ensure that their infrastructure is patched, applying any requiring operating system or web server stack component patches required. Unfortunately, when it comes to third parties, there is, however, little control that we have, and we have to largely trust that the third parties follow the same strict security guidelines that we ourselves do. It's because of this, and often the lack of security at the third parties, that is the reason attackers find going after third parties to be an attractive target. Code reviews are also a recommended must when it comes to security. An organization should look to have procedures in place to conduct strict code reviews as part of their QA. The challenge, of course, is that many of the third-party libraries contain thousands upon thousands of lines of code. And with an average of between 40 and 60 libraries per website, reviewing each one regularly is a daunting task, often unobtainable by many website developers. And then there are security standards which you can implement, such as CSP and SRI. CSP, or Content Security Policy Controls, can be applied and can specify what can happen within a website. For example, with CSP, we can mandate that JavaScript is not allowed to run, or when it is allowed, it is only allowed to come from specific sources. SRI allows us to ensure that any scripts we use remain unchanged by embedding a digital hash inside the pages to check against any loaded scripts. Unfortunately, with both of these mechanisms, whilst good standards, they are difficult to manage, especially on dynamic and constantly changing websites, and the configuration overhead often puts people off their usage. There are a number of solutions available which aim to complement CSP and SRI by providing dynamic management. However, these solutions are often just moving the management point as well and are actually not removing the problem of configuration overhead. And finally, there are third-party solutions which are designed to specifically mitigate web skimming attacks, and while they come in all different shapes and sizes, most operate on the premise at preventing data theft and exfiltration as a result of a web skimming attack. Ensighten provides one such technology which is designed to operate where the skimming attack actually happens, down in the browser. With a single line of code included within your HTML files, Ensighten delivers a small, lightweight and performance-focused library along with your existing code to create a security layer before any other script or code is allowed to load. With this layer in place, should a third-party or even a first-party script contain skimming malware and attempt to steal data, Ensighten implements a barrier, sees this at runtime and prevents it from happening. When Ensighten prevents a web skimming attack from happening, not only is the attack prevented, but an event is also raised alerting the developer about the existence of the malicious code and allowing a full loop security process to take place. And in closing, I wanted to leave off with why you can trust Ensighten to help you with your website security. Ensighten is the leader in website security and compliance, bringing a portfolio of technology designed to protect your website from new and emerging online threats and offering one of the most comprehensive compliance and privacy solutions to boot. Ensighten's approach to providing client-side website security and compliance is why Ensighten is used by many of the world's most valuable brands. With hundreds of enterprise customers, Ensighten's technology is designed to deliver a secure experience, but one that is performant to provide users with a great experience. So with that, I want to thank you for your time. I invite you to keep watching our webinar series as we put out new topics. And of course, if you want to learn more or see a demonstration of our technology, hit ensighten.com/request-a-demo and someone will get in touch with you to provide the information that you want. Thanks for your time, and I look forward to speaking to you again.